So what we have here is a battery pack from a power tool that has failed. About a year ago, I rebuilt it. I bought cells online, soldered the tabs together so I wasn't actually soldering directly to the batteries, which isn't good. Soldered up a whole new battery pack, put it back in the case. For a year, my dad used it and said that it worked great, had plenty of capacity, held its charge really good. And it worked great for about a year. Then one day he ran a couple screws into something and put down the drill. And a bit later he smelled something burning, ran around, checked a bunch of things, and he found that this battery pack had become very hot. The cells melted the bottom of the case. They melted the lid for the case. As you can see, this one here is pretty well burnt. If you flip them over, this one here on the bottom is burnt. This link here has gotten pretty hot. If you measure the voltage, this cell, this cell, this cell, and this cell are all dead. The other cells all still measure normal at about 1.3 volts. So I started trying to figure out what would cause a failure like this. One of the things I've seen in these packs is this wire back here that connects this upper battery on the connector that sits up in the tower on the battery pack can rub on this link here and short out. But that's not the failure mode here. There's no sign of that on the wire, and these cells on this end are all okay. So since it's this cell, this cell, this cell, and this cell, it has to be these short-circuited in a loop somehow and burnt themselves up. They were all good previous to the moment it failed, because he said the battery was operating normally. And then they all failed at the same time. If you look, these cells are just covered in a heat shrink kind of covering. They're split on the ones that got hot. But that's not the cause. That is a symptom of them overheating. This gouge here is where we had to pry it out of the case with a screwdriver because they stuck to the bottom. So what happened with these four cells? One thing I've learned with packs like this, when you have two batteries side by side linked together, positive and negative on the top, and they sit side by side like this, if the covering on the battery becomes damaged on, okay, this is the positive, so if the covering becomes damaged on these two cells and they connect together, you form a circuit. You have the negative of this battery connected to the case of this battery and through the tab right back to the positive, and it'll cook this battery. This one will be okay because the current's just going through the case, not actually through the battery, because there's no connection to the positive over here. But in this case we have four batteries that all failed. So if you open them up here and look, you can see that right in the bottom here, on this cell right here and this cell right here, the plastic shrink coating on the batteries has worn off, which would, when you touch those two together, that would create a circuit that includes this battery, this cell, this cell. It doesn't actually include this cell because this is the negative and the case is the negative. So the current went through these four cells. Let's see. Yes, that's positive. So through these four cells, from the case of this cell and through the case of this cell and back to this one. So it shorted out these four batteries. And this one didn't get taken out because even though its cover was damaged, the current just went through the case, not through the actual battery. So these are sitting in the case like that, these five cells together. It wore here and shorted out internally and got very hot. So I got to thinking, when I rebuilt the battery, the old cells came with these nice cardboard sleeves that slide over. A lot more durable than the heat shrink covering that the new cells have. The old cells, if you take one of these batteries, bend the tab out like that, it won't even fit into the old cardboard tubes. So I think they're getting a little extra capacity out of these new cells by making them slightly bigger to put a nice thin heat shrink covering on them, and then they can be slightly larger and have a little more capacity. So now the question is, what do we do to prevent this failure? I have several other batteries that I built with these same cells. And if they rub around inside, I could see this happening on the others as well. So I'm thinking what I'll do with all the other ones is take them apart, and I could cut these tubes down the side a little bit, slide them on anyway, and make sure that the side that split is out so it doesn't, allow the other cells to make contact. Or I could wrap some paper around them or something like that, I suppose. Thought about, wide electrical tape or something, or packing tape or something like that, but the cells can get pretty warm under use, and I'd rather use something that can't melt with the heat. So that's about it. That's what happened. Don't trust batteries with thin heat shrink on them, I guess.